Hello students, in the present video I'll explain spec rating and its significances. We'll take one problem here. Explain clearly spec rating and its significance. Assuming that the reference computer is Ultra Sparsio workstation with 300 MHz Ultra Spark processor. A company has to purchase 1000 new computers, hence order testing of new computers with Spec 2000. So following observations were made for different programs like program 1, program 2, program 3 and program 4. Runtime on reference computer as well as runtime in new computer is listed in a table format. For program 1, runtime on reference computer is 50 minutes. Runtime in a new computer is 5 minutes. Similarly, for program 2, runtime on reference computer is 75 minutes. Runtime in new computer is 4 minutes. Similarly, for program 3, runtime on reference computer is 60. Runtime in a new computer is 6. And for program 4, runtime on reference computer is 30 minutes and runtime in a new computer is 3 minutes. So now the company system manager will place the order for purchasing of new computers only if the overall spec rating is minimum at least 12, that is minimum 12. After the set test, will the system manager will place the order, that means will place order for purchase of new computers or not. So now we have to compute the spec rating for different programs like program 1, 2, 3 and 4, and later we have to compute the overall spec rating and we have to compare with the given spec rating, that is 12. So if it is at least equal to 12, the system manager will place the order for purchase of new computer. If it is less than 12, the system manager will not place the order for purchase of new computers. Here we can observe that the performance measure is the time taken by the computer to execute a given benchmark. A non-profit organization called Spec, that means System Performance Evaluation Corporation, selects and publishes the benchmarks. So we can compute the spec rating is equal to running time on a reference computer, that means the ratio of the running time on a reference computer to the running time on a computer under test. So now we are having for program 1, running time on the reference computer is given it as 50 minutes and the running time on the running time in a new computer is given it as 5. So now I have to compute the spec rating for program number 1. So that is equal to running time on the reference computer, that is 50 minutes, divided by run time in new computer, that is 5, will get the value as 10. So next comes the spec rating of program 2. So that is 75 divided by 2. And the spec rating of program 3, that is equal to 60 by 6, and spec rating of program number 4, that is equal to 30 by 3. So now we computed for different programs, we already computed the spec rating. So now finally we have to compute the overall spec rating. The overall spec rating is equal to pi, I is equal to 1 to n, spec I to the power n. So where n is equal to number of programs. So here we are having the value of n is equal to 4. So now the overall spec rating, that is equal to I is equal to 1 to n, that is spec I to the power 1 by n. So that means 10 into 18.75 into 10 into 10 to the power 1 by 4, that is equal to, we will get the value as 11.70. So now we got the overall spec rating as 11.70. So now I have to compare this value with the given value, that is 12. The system manager will place the order only if it is at least 12. The overall spec rating or benchmark if it is at least 12. Since the rating is the spec rating we computed is 11.7, which is less than the benchmark rating, that is 12.00. So therefore the system manager will not place the order in order to purchase the new computer. So this is the solution for first problem. So we'll take the next problem. A program contains 1000 instructions. Out of that, 25 instructions requires 4 clock cycles, 40% of instructions requires 5 clock cycles, and remaining requires 3 clock cycles for execution. Find the total time required to execute the program running in a 1 GHz machine. So now we'll take the solution. So we are having the total number of instructions as capital N is equal to 1000. So out of 1000, 25% of instructions, that is 25% of N. So that means out of 100, 25 instructions. So if you are having 100 instructions, 25 instructions will require 4 clock cycles. Similarly, if you are having 1000 instructions, out of 1000 instructions, what is the value? So 1000 into 25 divided by 100, you will get the value as 250. You get the value as 250. 25% of N means out of 100 is 25, out of 1000 how much? So you'll get the value as 250, which requires 4 clock cycles. So 40% of N means 400 instructions and which requires 5 clock cycles, and remaining percentage, that means 100 minus total means 100%, 100 minus 25 plus 40. So we'll get the value as 35. So remaining instruction means 35% of N. 35% of N means 350 instructions, which requires 3 clock cycles. So now how to compute capital T. So what is the equation to compute capital T? So that is equal to N into S divided by R. So N, the total number of instructions we considered with respect to the clock cycles, like 250 into 4, 400 into 5, 350 into 3. So total number of instructions with the clock cycles divided by 1 into or divided by 1 gigahertz, that means the clock rate. So now that is 1 into 10 raised to 10 to the power 9. So that means 250 into 4 is equal to 1000, 400 into 5 is equal to 2000, 350 into 3 is equal to 1050 divided by 1 gigahertz. So we'll get the final value, that means the total time required to execute the program, that is equal to 4.05 microseconds. So we'll take the last problem. For the following processor, obtain the performance. The clock rate is given as 800 MHz. The number of instructions N is equal to 1000. The average number of steps required in order to execute the program, capital S is equal to 20. So now how to compute T. T is equal to, we know the equation, T is equal to N into S divided by R. So N is equal to 1000 into 20 divided by R means 800 megahertz, that is the clock rate, 800 into 10 raised to 6. So we'll get the final value as 25 microseconds or 25 into 10 raised to minus 6 seconds.